Hello everyone, I am Miss Afifah from Group 1 will introduce our experiment which is a homopolar motor. Basically, a homopolar motor is a type of electric motor that use direct current to power rotational movement, such as generated by a battery. It was the first type built and demonstrated by Michael Faraday in 1821. A homopolar motor can be made from a single AA or C battery, a single neodymium bismagnet, and a piece of copper wire. They have two magnetic poles provided by a single permanent magnet to produce a magnetic field, also required to generate rotational movement. It is called a homopolar motor because, unlike conventional DC motor, the polarity of the magnetic field emitted by the conductor and the permanent magnet does not change. Let us take a look at the theory.
Lorentz force. What is Lorentz force? Lorentz force is a force that exerted on a charged particle Q which moves with velocity symbolizes V through an electric field E and magnetic field B. All the electromagnetic force F on the charged particle is called Lorentz force. The equation is F equal QE plus QV times B, which Q is charged particle, V is velocity, E electric field, and B magnetic field. It is contributed by electric field and magnetic force. The magnetic force has a direction which perpendicular to velocity and magnetic field. Magnetic force is proportional to Q and to magnitude of cross product of vector V and B, which is V times B. Did you know? One of the results in Lorentz force is the motion of charged particle in a uniform magnetic field. Let's say if V is perpendicular to B, the particle will follow a circular trajectory with radius r equal mv divided by qb. While if less than 90 degree, the orbit will be helix with axis parallel to field lines, and if 0 degree, there will be no magnetic field lines.
Just imagine a simple homopolar machine. From this battery, you have a wire and the magnet at the bottom of the battery. So from the experiment, we can see that once the magnet was placed, the wire was gradually increasing the speed. So what we can see from it is that how the wire moves and create a rotational movement. This is due to the Lorentz force. What is really happening here is the electric current from the positive terminal of the battery into the negative terminal of the battery and lastly into the magnet. So this current then flows from the center of the magnet. It goes to the edge where the wire is connected and it goes back to the positive terminal. And this is how the circuit is complete. So the key here is that the direction of the current and the magnetic field produced by the permanent magnet, it generates the rotational movement here. So this is what we can see from this experiment.
For the application of Lorentz force occur in many devices such as cavity magnetron. The cavity magnetron is a high-power vacuum tube that generates microwave using the interaction of a stream of electrons with a magnetic field while moving past a series of open metal cavities or cavity resonators. Second application is mass spectrometry. Mass spectrometry is an analytical technique that measures the mass-to-charge ratio of ions. Mass spectrometry is used in many different fields and is applied to poor sample as well as complex mixture.
The conclusion is the homopolar motor follow the Lorentz force. The electrical current flows from the battery's positive terminal to the negative one and through the magnet. These currents flow from the center of the magnet to the edge where the wire connects. It travels out the wire back to the battery's positive terminal and the circuit is complete. The key is the direction of the current and the magnetic field produced by the permanent magnet. The direction of the magnetic field is demonstrated by the red arrow and the direction current is shown by the blue arrow. As the current travels perpendicular to the magnetic field, a Lorentz force is exerted on the conductor, which is the wire, which again is perpendicular to both the direction of the magnetic field and the current, generating the spinning motion.